Hello, this lesson is topic 3.4, solving proportions. Today we'll find the unknown number in a proportion and we'll look at unknown numbers in proportions with mixed numbers, fractions, and also decimals. When we solve proportions today, we're going to do so using basic algebra. We're going to solve an equation for which there's a missing value, and usually you'll see this as expressed as x, sometimes n, but you can use any number to show a missing value. The important thing to know when we solve equations is that we have a goal, and the goal is to keep the equation balanced. So we keep units matching, and in this lesson we don't have units, but in the future we will. And then we look for the balance, so we want to have what we do on one side of the equal sign happening on the other side as well. In Module 1, we looked at equivalent fractions and how to solve for a missing numerator usually. And how we did that was by looking at what we have matching in the denominator. So we have 5 and 20. So we ask ourselves, well, how do I get from 5 to 20? I multiply by 4. And because I did that in the denominator, I have to do the same in the numerator. So 4 times 4 is 16. So we were able to solve that way. And it's the same with number 2. We looked at 9 and 54. Okay, I have to multiply 9 times 6 to get to 54. So I have to multiply 7 times 6, and that equals 42. So we're able to make equivalent fractions through multiplication. For number 3, we did so using division. We looked at 15 and 75, and we can work backwards if we want. Well, how do I get down from 75 to 15? What do I have to divide by? I divide by 5, and so therefore I can divide 20 by 5, getting me down to 4. So using this method is a really good method, but it doesn't always work for numbers that become more challenging. So we'll take a look at some of those examples up next. For this first example, we can use two different methods in order to solve for x. The first method is the one that we learned in Module 1. The numbers are basic enough that I can say to myself, well, 5 times 6 makes 30, so 4 times 6 makes 24. So this is the equivalent fraction method. This works well if the numbers are simple. The second method we're going to focus on in this lesson, though, is using algebra. So we are going to solve using algebraic method. So in this method, we take 4 over 5 is equal to x over 30, and what we do is we cross multiply. It does not matter which side you put the numbers on. So for example, it does not matter if you do 4 times 30 and put that on the right-hand side of the equal, or 30 times 4 on the left-hand side. That does not matter. All that matters is that the numbers are multiplied and placed on either side of the equal sign. So I'm going to multiply 30 times 4 over on the left-hand side. And on the right-hand side, I'm going to multiply 5 times x. And notice that I'm using a raised dot instead of the multiplication symbol, simply because I have x here, so it would look kind of weird to have 5xx. Later on, we'll drop using the raised dot with x, but for now, it's good to show that we're multiplying two things on both sides of the equal sign. So let's solve what we can. Over on the left-hand side, 30 times 4 gives 120. And that's equal to 5 times x. Well, 5 times x can be expressed as 5x. We don't need to have a symbol between. Now, what we're doing to x over on the right-hand side is we're multiplying to x. So we want to get x by itself. So because we're multiplying to x, we have to do the inverse operation to remove the 5 from x. So we're multiplying 5 times x, so then we're going to divide it. Because 5 divided by 5 is equal to 1, and 1 times any number is just going to be that same number. But what I do to x, division by 5, I must do on the other side of the equal sign. I must have balance. That's very important. So I'm going to divide by 5 on both sides, and 120 divided by 5 is 24, and we saw that in our answer above. We know it's 24, and this proves it. So 24 is equal to x. It's a little bit backwards for most folks, so I just rewrite it usually. X is equal to 24. For the second example, we can use the first method again because the numbers are basic and we can raise the terms. So I look here and say, well, 1 goes up to 3 by multiplying by 3, so 5 times 3 is equal to 15. So by using equivalent fractions, that method works. So we can use equivalent fractions for this one. Or we can use algebra. And when we do that, we're going to cross multiply. So let's set that one up. 3 over x is equal to 1 over 5. So it doesn't matter where x is. And this time I'm going to place x over on the left-hand side. So I'm going to cross multiply. 1 times x is equal to 3 times 5, or 5 times 3. Doesn't matter the order that you put it. Okay, so 1 times x is 1x is equal to 3 times 5 is 15. Well, 1 times x is the same thing as x. So technically we could divide 1 divided by 1 and 15 divided by 1 to cancel. But we don't actually even have to because 1 times x is just x. But it's good practice. So x is equal to 15. For example 3, we have fractions. So when we have fractions, it's going to go a little bit more slowly. And we can see here that using that equivalent fraction method, that's not going to work very well. Going from 1.5 up to 4.5, we don't quickly have a number in our head. So this one we really are bound to cross multiplication. So we're going to multiply 1.5 times x and 4.5 times 1/6. So I'm going to put that here. 1.5 times x is equal to 4.5 times 1/6. So I'm going to solve over on the right-hand side. 4.5 times 1/6, that means I have to change to an improper fraction. So I'm going to do that over here for space. So that's going to give me 9 over 2 times 1 over 6. And I can cross reduce here. I'm going to divide by 3 and divide by 3. So that's going to give me 3/4. Over on the right-hand side. On my left-hand side, I have 1.5 times x. Well, I'm going to change that 1.5 to be 3 over 2 times x is equal to 3/4. So now, as we learned before, because I'm multiplying to x, I have to get rid of that 3 over 2 through division. So I do the inverse of what is happening to x. If you're multiplying to x, then you must divide. So I'm going to divide by 3 over 2, which cancels that, because 3 over 2 divided by 3 over 2 is equal to 1. And then I have to do the same thing on the other side of my equal sign. So x is going to be equal to 3/4 divided by 3/2, which we know needs to change to multiplication, and we need to flip to the reciprocal. I can do some cross-reducing here. 3 divided by 3, right, is 1. And then I've got a 2 and a 4 on the other side. So 2 divided by 2 and 4 divided by 2. So when we divide these numbers, we end up getting 1/2. So x is equal to 1/2. The next video will take you through the do together and another example in the exercise.